Imagine a time when humanity dared to send a message to the stars, not knowing if anyone or anything would ever hear it. Picture a small, boxy spacecraft, no bigger than a golf cart, hurtling through the void of space, carrying a golden plaque, etched with symbols of who we are. This isn't science fiction. This is the story of Pioneer 10 and Pioneer 11, the first human-made objects to escape the inner realms of the solar system, blazing a trail into the unknown more than half a century ago. These modest probes, launched in the early 1970s, defied expectations, expanded the boundaries of possibility, and planted the seeds for humanity's dreams of interstellar exploration. What did these spacecraft discover billions of miles from home? And why does their journey still matter today? To understand, let's rewind to 1972. The world was in flux. Disco was on the rise, calculators were considered cutting-edge technology, and NASA was preparing to take a bold leap that would redefine space exploration. The agency had an ambitious plan: send a spacecraft farther than any had gone before, past Mars, through the perilous asteroid belt, and onward to Jupiter, the king of planets. No one had ever attempted such a feat. The distances involved were immense and the dangers were daunting. Jupiter, after all, lay 10 times farther from Earth than Mars and was surrounded by powerful radiation belts and mysterious storms. But NASA didn't stop there. They envisioned a second mission that would go even farther, to Saturn and beyond. These were the Pioneer missions, and they marked humanity's first steps into the deep end of the solar system. Pioneer 10 launched on March 2, 1972, aboard an Atlas Centaur rocket. Its twin, Pioneer 11, followed a year later. Each spacecraft weighed just 570 pounds, about the weight of a motorcycle, and was powered by a nuclear battery no larger than a toaster. These weren't sleek, modern machines equipped with artificial intelligence. Their computers had less memory than a digital watch, and their transmitters used about as much power as a refrigerator light bulb. Yet these humble probes were built to do what no spacecraft had done before: survive the uncharted perils of deep space and send back data from regions we could only dream of reaching. Their journey was far from easy. To reach Jupiter, the pioneers first had to cross the asteroid belt, a treacherous stretch of space filled with rocks ranging in size from tiny pebbles to mountains, all zipping around at 45,000 miles per hour. Scientists held their breath. A single collision with a stray boulder could end the mission in an instant. But the pioneers navigated the cosmic minefield with astonishing precision, proving that the asteroid belt was not the impassable barrier it was once feared to be. In December 1973, Pioneer 10 became the first spacecraft to reach Jupiter. It sent back grainy but jaw-dropping images of the gas giant's swirling storms and its massive Great Red Spot, a hurricane large enough to swallow Earth 3 times over. What it found was far stranger than scientists had imagined. Jupiter wasn't just a beautiful planet with colorful cloud bands. It was a ferocious giant. Its magnetic field was 20,000 times stronger than Earth's and emitted intense radiation that could destroy spacecraft electronics in moments. Pioneer's instruments detected streams of charged particles racing through space, composing a cosmic symphony of energy. Even more astonishing were the moons. Pioneer 10's cameras captured Io, a volcanic world spewing sulfur plumes into space, and Europa, a smooth, icy moon believed to hide a vast ocean beneath its frozen crust. These weren't dead rocks orbiting a planet. They were dynamic worlds, and they redefined our understanding of the solar system overnight. Pioneer 10 didn't stop at Jupiter. Using the planet's gravity like a slingshot, it continued on toward the outer solar system. Pioneer 11 took things even further, reaching Saturn in 1979 after a detour past Jupiter for additional data. Saturn, with its iconic rings, was even more magnificent than telescopes had suggested. The rings, composed of countless fragments of ice and rock, danced in delicate, intricate patterns. Pioneer 11 also glimpsed Titan, Saturn's largest moon, shrouded in a dense orange haze. A hint at mysteries were still unraveling. But what makes the Pioneer missions truly remarkable isn't just what they discovered. It's how far they went. By the 1980s, both probes were on trajectories that would take them out of the solar system entirely. In 1983, Pioneer 10 crossed the orbit of Neptune, becoming the first human-made object to travel beyond the planets. Pioneer 11 soon followed. They were now in uncharted territory, where the sun's light is a mere glimmer and Earth is just a pale dot lost in the cosmic sea. Their nuclear batteries were fading, and their signals were weakening, yet they continued, whispering to us across billions of miles. One of the most profound moments came in 1990, when Pioneer 10 was more than 4 billion miles from Earth. Scientists sent a final command to turn its camera back toward our planet. The image was faint, barely a pixel, but it captured something extraordinary. Earth, a tiny speck in the vast darkness. It was a humbling reminder of our place in the universe, a perspective that continues to resonate. By 2003, Pioneer 10 sent its last signal, too weak to be received by Earth's antennas. Pioneer 11 had gone silent in 1995. But silence does not mean failure. Both probes are still out there, drifting at 27,000 miles per hour toward the stars, carrying a message for anyone or anything that might one day find them. That message is the Pioneer plaque, a gold-anodized aluminum plate affixed to each spacecraft, designed by astronomers Carl Sagan and Frank Drake. It is a cosmic postcard, etched with symbols meant to communicate who we are to an alien civilization. It features drawings of a man and a woman, a silhouette of the spacecraft for scale, and a map showing Earth's location relative to 14 pulsars, cosmic lighthouses, that flash with precise regularity. There's also a diagram of the solar system and the hydrogen atom, a universal constant that any advanced species might recognize. It's a long shot, but the plaque is our way of saying, we were here, we dreamed, we reached out. Even more astonishing was what the pioneers revealed about the edge of the solar system. As they ventured farther, they approached the heliopause, the boundary where the sun's influence gives way to the vastness of interstellar space. Scientists once thought this would be a sharp boundary, a clean divide between solar wind and the galactic void. But the data told another story. The heliopause was turbulent, chaotic, more like the edge of a stormy sea than a neat frontier. Despite their rudimentary instruments, the pioneers detected fluctuations in cosmic rays, high energy, particles from ancient supernovae, hinting at a dynamic transition zone. These discoveries laid the groundwork for what the Voyager spacecraft would later confirm. Interstellar space is not a silent, uniform vacuum, but a complex frontier shaped by stellar explosions and galactic winds. The Pioneer missions didn't just advance science, they changed us. They proved that even with 1970s technology, humanity could reach for the stars. Their images of Jupiter's moons inspired later missions like Galileo and Juno. Their data on Saturn and Titan helped pave the way for Cassini's epic journey, and their plaques sparked imaginations around the world, influencing everything, from science fiction novels to blockbuster films. Most of all, the pioneers showed that we could dream beyond our limitations. Built with slide rules and punch card computers, these probes outlived even their creators' wildest hopes. Today, Pioneer 10 and 11 are silent travelers, coasting through space toward the constellations Taurus and Aquila. They won't reach another star for millions of years, but their mission was never about arrival. It was about the courage to begin the journey. Scientists estimate that in roughly 2 million years, Pioneer 10 might pass within a light year of a red giant star called Aldebaran in the Taurus constellation. Will someone or something find it? Will they decode the plaque and wonder about the species that sent it? We'll never know, but that's not the point. The pioneers are a testament to our innate need to explore, to ask questions, even when answers are out of reach. Their legacy lives on in every space mission that followed. When Voyager crossed the heliopause, it did so on a path first charted by the pioneers. When New Horizons zipped past Pluto, it carried their spirit of exploration. As we now plan missions to Mars, Europa, and beyond, even interstellar probes, we remember that the impossible is only a challenge we have yet to overcome. Their data, still archived at NASA, continues to be studied. Every faint signal, every spike in cosmic rays, is a clue to the greater puzzle of our place in the cosmos. And yes, in 2025, the story of Pioneer still matters. It holds up a mirror to our species and shows what we can achieve when we push past fear and doubt. In a world grappling with climate change, pandemics, and uncertainty, the success of the pioneers reminds us that human ingenuity can triumph over the most daunting challenges. Their plaques, drifting silently toward the stars, are more than artifacts. They are symbols of hope. They proclaim that we are more than our struggles, that we dared to dream and reached out into the unknown. From Io's volcanic eruptions to the churning chaos of the heliopause, the pioneers revealed a universe filled with wonder waiting for us to uncover.